This is the final topic we're going to talk about for logarithms this chapter. So we're going to take all of our knowledge of logarithms and finally put it all together. And we're revisiting those good old interest problems, except for in this case, now we're talking about populations. So we're going to use properties and all that good knowledge of logs and natural logs to solve some actual application problems. These three problems are actually part of your assignment, so you don't have to go ahead and do these again. You can if you want, just to get extra practice, but you don't have to. So let's go ahead and start. This problem says, hey, we're looking at above the poverty level. So we say in a country there's 28 million people currently above the poverty level, and it's growing 5% annually. They actually give us an equation for this. Now it looks like PERT, and it is, except for they said, hey, instead of A, we're going to use population equals. So don't be fooled by having the P out front there. Then we're going to look at below the poverty level, and then we're going to talk about how we could solve a problem when they're equal to each other. So first, let's figure out, this asks, how many years will there be 40 million people above the poverty level? So the population will be 40 million. So 40 million people equal to 28e.05t. Again, we've seen formulas like this when we were trying to find time before. To do that, we need to get this exponent down, so we need to take natural log. But in order to do that, I want to make sure that e is isolated first. So divide both sides by 28 to start. I'm actually going to reduce that fraction to 10 sevenths. So I have 10 sevenths equals e to the 0.05t. Now, again, to get rid of e, we need to take the natural log. So I'm going to do the natural log of 10 sevenths equals the natural log of e.05t. And again, that's where you realize, oh, hey, natural log of e is just 1. And then I have that power rule. I can bring down 0.05t times 1. So now I have the natural log of 10 sevenths equals 0.05t. So in order to finish this problem off, I want to solve for t, so I need to divide by 0.05. So the natural log of 10 sevenths divided by 0.05 equals 0.05t divided by 0.05. So t, let's go to our calculator here to figure this out. We're going to do the natural log, so that natural log button, of 10 sevenths, and then make sure you close your parentheses to divide by 0.05. And we get 7.11. And we're talking about how many years, so we're talking about 7.11 years. Right? Below the poverty level is exactly the same setup, same process of going through, so you can try this one on your own if you want, or follow the video if you need a little bit more guidance again. So again, 40 million people is what we're trying to go to. So 40 million equals different formula now, so be careful there. 20e.07t. Again, we need to isolate e. So we get 2 equals e.07t. To get e to go away, we need the natural log of both sides. And again, we know the natural log of e is 1, and powers can come on down. So now I have the natural log of 2 equals 0.07t. Divide both sides by 0.07, and I end up with t equals 9.9 years. So now the next question, like I said, is a little bit different. It says, in how many years will the people above the poverty level equal the people, or people below equal the people above? So I want to equal something. Well, what should I equal? The people above to the people below, or below to above. So people below is represented by that 20 e to the 0.07t equals the people above the poverty level, 28 e to the 0.05t. Now you may say, like, oh hey, they both have e's, so I can get rid of the e's, but they're different exponents. So how would I want to tackle this? Think back to when we had same or different bases. What did we have to do? We have to take the natural log of both sides, or the log. So take the natural log of 20 e 0.07t equals the natural log of 28 e to the 0.05t. Now you should realize in here that there is a product going on. Because there's a product, we can pull these apart. So go ahead, pull it apart. We get the natural log of 20 plus the natural log of e 0.07t equals the natural log of 28 plus the natural log of e 0.05t. And now you should be saying, like, hey, I have natural log of e. I can get rid of that and bring the power down. Same thing on the other side, bringing the power down. So now we have the natural log of 20 plus 0.07t equals the natural log of 28 plus 0.05t. Now, in order to solve this, I want t all on one side, and I want the natural logs all on one side. So I'm going to subtract 0.05 to get t on the left. And at the same time, I'm going to move this natural log of 20 to the other side. So again, that's going to go away. That's going away. So I have 0.02t equals the natural log of 28 minus the natural log of 20. And at this point, you should be like, oh, hey, I know that that's a property here. Minus, quotient rule, rewrite it. You don't have to, but I think it's easier to rewrite it. So 0.02t equals the natural log of 28 divided by 20. And you can reduce the fraction if you want, but you don't have to. And then divide by 0.02. And that's going to end up giving you a t of 16.82 years. That is when they will be equal to each other. Now, this may seem like a lot of work, so I'm actually going to show you how you can do this in your graphing calculator. And you may recall from doing systems of equations, doing those in your graphing calculator or graphing them by hand. So, if you go to y equals and you put in the two functions, so 20, I have e raised to the 0.07 x, you can't use t because t is just not a function on your calculator. We have to use x instead. And 28 e raised to the 0.05x. Well, we want to know when they're equal, so that's when they should intersect on the graph. Now, my window is already zoomed out. With these functions, chances are you're going to have to zoom out a lot to get them. So in order to do that, you need to go and pick an appropriate window. So I said, hey, I know it's going to be a large y value, so I went all the way up to 100. I know that it's probably going to be an x value that's around anywhere from 5 to 20. It could be a little bit less, so that's why I said, hey, I'll just go to 30. And that's where I got my window. Now, to get that intersection, recall from chapter 10 when we worked with kind of the calculations. If you hit second calc, you can find an intersection. All you have to do is go to intersect and follow the on-screen directions. It says first curve, so pick a point somewhere close to it. Second curve, make sure you're on the second curve. Pick a point closer or anywhere, and then you guess. And it says, hey, intersection. So if you can see that on the screen here, it says 16.82, and the population it actually gives you is 64.93 million people. So again, going through those steps in your graphing calculator, one, you're going to enter your equations into y equals. Step 2, you're going to graph it. Step 3, you need to find an appropriate window. And what I mean by appropriate window is you should be able to see the intersection on your screen. 4, you go to Second, Calc, which is Trace. Oops. And then you want to find out where they intersect, so you hit Intersect. And from there you follow the on-screen directions. And that is how you would do it in your graphing calculator. And that concludes our logarithmic explorations.